Okay, so a real world problem using vectors, swimming. So Ali rows due east at a speed of 3.5 feet per second across a river directly towards the opposite bank. At the same time, the current of the river is carrying him due south at a rate of 2 feet per second. Find Ali's speed and direction relative to the shore. So the first thing we need to do is draw a diagram. So we have a vector which is 3.5. So let's do a north, east, south and west. So Ali rows east at a speed of 3.5 feet per second. So 3.5 feet per second. So this is going to be on our vector this way, in this direction. And then it says across the river directly towards the opposite bank. At the same time, the current of the river is carrying him due south. So the current of the river is taking him down to the south. And this is at a rate of 2 feet per second. So we need to find Ali's speed and direction to the shore. So we can draw, so we're going to have, this is going to be the vector, which is going to we're going to call G. So we have a right angled triangle. So this here is 2 feet per second, 3.5 feet per second, and this is G. So we can use Pythagoras. So we know that these two sides squared are going to be equal to this side squared. So G squared is equal to 3.5 squared plus 2 squared. So G will be the square root of 3.5 squared plus 2 squared. And if you put that into the calculator, this is going to be roughly 4.03 feet per second. Okay, so now we need to find the direction, and we're looking at this angle here, and we need to find this. So we're going to use trigonometry. So for right angle triangles, so we're going to use opposite over adjacent. So we're going to use tan. So tan is opposite over adjacent. So we want the tan of the angle is equal to 2 divided by 3.5. So to find the angle is going to be tan to the minus 1, 2 divided by 3.5. So our angle of theta will be 29.74 degrees. So we're going to round this to the nearest, to 30. And the direction, so we're looking at between east and south. So angle from okay, so if we go back to our original diagram, this angle here, theta, is, we said 30 degrees. So this angle here going to be 60 degrees. So we can say that Ali's speed relative to the shore is about 4.03 feet per second, and the direction is going to be south 60 degrees of east, so southeast 60 degrees. Or if we were to write this as a three-figure bearing, we could say for 120 degrees.